Hi everyone and welcome to another episode of STEM in Seconds. As you can see, today we're going to be talking about indices, what they are, how we use them, and what the rules are regarding them. So let's start with what an indice is. Say you have an expression such as 2 times 2. Very simple, and we know that equals 4. And that's nice and easy, but what happens when you start to have an expression like this? That's a little more ugly on the piece of paper, so we know it equals 32. But instead of writing 2 5 times out, because that's a bit time consuming, we instead can write this as 2 to the power of 5, which means 2 multiplied by itself 5 times. So that's the basics of an indice, and any number can be raised to nearly any power, so you can have something like 3 to the power of 6, or 5 to the power of 3. And they all mean the same thing, 5 multiplied by itself 3 times. Now, in terms of the lingo, here is the expression 2 to the 5. This 2 here is called the base. And this 5 we refer to as the exponent. Now, sometimes you end up with expressions with 2 indices. You have to learn how to combine these two. As long as you follow a couple of simple rules, it should be relatively easy for you to simplify your indices. So let's start with the basic expression of 2 to the 5 multiplied by 2 to the 2. Now the rule for this is if you are multiplying your bases, you add your indices. So that gets you equal to 2 to the power of 5 plus 2, which equals 2 to the 7. This works in reverse for if you're dividing. For example, 2 to the 5 divided by 2 to the 2 is the same as 2 to the power of 5 minus 2, which equals 2 to the power of 3. Now, again, this only works because I've got a 2 here and 2's here. You cannot use these rules unless your bases are the same number. Now there's one more rule in this set, and that is if you have brackets. So for example, 2 to the 2, all raised to the power of 3. Now this, when it's raised to a power, means you have to multiply your indices. So you end up with 2 to the power of 2 times 3, which gets you 2 to the power of 6. Now we've mastered the basic indice rules, we're going to move on to some slightly more complicated ones. These will likely come up in a GCSE or A-level or higher level of paper. We're going to look at negative and fractional indices. The first one we're going to look at is 2 to the power of minus 1. Now the rule with a negative indice is it indicates a reciprocal. So this is equal to 1 over 2 to the power 1. The negative doesn't change the numerical value of the power, only reciprocates the base. This means that, for example, when we would have 2 to the power of minus 3, you end up with 1 over 2 cubed. The numerical value of the power hasn't changed, only become positive in the reciprocal of this number. The next thing to look at is when you have a fractional indice. For example, 2 to the half. Now a fractional indice means that there is a root in the simplified version. So I know that I am going to have a root of 2 to the 1. Now because this denominator here is a 2, I know it is the square root of 2 to the 1. This means if I had 2 to the third, again, I would have a root of 2 to the 1 because 1 is in the numerator, and then this 3 means it is the cubed root of 2. Now one more fractional indice is if you have a different number in the numerator, for example 2 to the power of 2 over 3. Again, I have a root, I know there's a 2 in there, there's a 3 in the denominator, so I know it's a cubed root. There is an index on this 2 here, and the index on the 2 will always be equal in value to the numerator, so this is the cubed root of 2 squared, otherwise known as the cubed root of 4. Now the final thing we're going to do today is to look at a worked example. As you can see, I want you to simplify 2 to the power of minus 2 over 3. If you want to pause the video here and have a go yourself, go ahead. For those of you who have a solution, I'm going to work through it now, so check your answer. So the first thing I want to do is get rid of this irritating minus because it makes the fraction much more difficult. So I'm going to reciprocate this 2, 1 over 2. Numerical value of the power doesn't change, so it's to the power of 2/3, but I've gotten rid of the minus. Next thing I'm going to do is expand this fractional power. It's a fractional power, so I know there's a root involved. So we're looking at 1 over a root of 2. This denominator is a 3, so it's a cubed root. And this numerator is 2, so it's 2 squared. So this fraction simplifies to 1 over the cubed root of 4. For those of you who got it right, congratulations. I've got one tougher one for you to try, which is 2 to the power of minus 3 over 2. Pause here if you want to have a go. I'll be using a very similar method to last time. Again, first thing you do is you get rid of this minus, so you get 1 over 2 to the power of 3 over 2. Then again, I know this fraction means that there is a root involved, so it is 1 over a root of 2, because 2 is the base. There's a 2 in this denominator, so it's a square root of 2, and the numerator is 3, so it's a square root of 2 cubed. Now, for those of you who are quick on your calculators, you will know that 2 cubed is the same as 8. So we're looking for the square root of 8. For those of you up to date on your surds, I want you to continue and simplify this because we get 1 over square root of 4 times the square root of 2. And square root of 4 is just 2. We're going to take the positive square root here. So you end up with 1 over 2 root 2. To further simplify this, although some boards may not require you then rationalise this denominator. I will do another video on this, so if you're stuck, feel free to click on that. But here we go. So I'm going to take 1 over 2 root 2, and I'm going to multiply each side by 2 root 2, which gets me 2 root 2 on the top, and 4, 2 times 2 is 4, multiplied by root 2 times root 2, which is 2. So you end up with 2 root 2 over 8. There is now a common factor of 2 between this 2 and this 8, which leads me to root 2 over 4. For those of you who got that, congratulations. That's the end of this video. If you have any ideas for further videos, please comment down below and don't forget to subscribe.